We have learned about different plane figures like square, rectangle, circle and triangle. Now, when we give either depth or rotation to these 2D figures, they get converted into 3D figures. For example, if I take a square and give depth to this square and rotate it, it gets converted into a cube. Similarly, if I take a rectangle and give depth to this rectangle, you will find that this rectangle has converted to a cuboid. Now, instead of giving depth, if I rotate these 2D figures, for example, if I take a rectangle and rotate it, you will obtain another solid which is nothing but a cylinder. Similarly, a right angle triangle on rotating, you will get a cone. What about the case of a circle when we rotate? A circle when rotated, you will get a sphere. Well, we got a sphere. Now, from a sphere, we can obtain another solid figure which is a hemisphere. What is a hemisphere? It is a half of a sphere. These are the basic solids: cube, cuboid, cylinder, cone, sphere and hemisphere. These basic solids have 3 dimensions: length, breadth and height or depth. Surface area and volumes of these basic solids can be easily calculated using simple formulas. Formulas for calculating surface area and volume of basic solids. How can we find it? Remember, we specify lateral surface area for cube and cuboid and curved surface area for cone, cylinder, sphere and hemisphere. For a cube, lateral surface area is 4a square, while the total surface area is 6a square and the volume is a cube. For a cuboid, lateral surface area is 2 into L plus B into H and the total surface area is 2 into LB plus BH plus LH, while the volume is L into B into H, where L stands for length, B stands for breadth and H stands for height. Now, for a cylinder, curved surface area is 2 pi RH and the total surface area is 2 pi R into R plus H, and while the volume is pi into R square into H. Now, for the case of a cone, curved surface area is pi RL and the total surface area is pi into R plus L. Now, what about the volume? Volume is 1 by 3 pi R square into H. Now, come to the case of a sphere. What is the total surface area? Total surface area is 4 pi R square and the volume is 4 by 3 pi R cube. Now, for a hemisphere, curved surface area is 2 pi R square and the total surface area is 3 pi R square, while the volume is 2 by 3 pi R cube. Surface area of combination of solids. Many times in our day-to-day life, we come across many objects which are a combination of 2 or more basic solids. Here we are particularly going to discuss the surface areas of a combination of solids. Now, why do you think an understanding of surface areas of composite solids is important? Understanding the way of computing or determining their surface areas is important as we encounter them in our daily life. Surface area is important to know situations where we want to wrap something, like wrapping a gift box, paint something, or eventually while building things to get the best possible design. Now, there will be a question that arises in your mind. What is the difference between area and surface area? Area, it is a measurement of the size of the flat surface in a plane. It is a 2-dimensional measurement. Whereas surface area is a measurement of the exposed surface of a solid shape and it is a 3-dimensional measurement. Now, let's see the strategy to solve problems. Try and see which basic solids like cone, hemisphere, cylinder, cube, etc. make the given complex solid. Next, find the curved surface areas of each of the individual basic parts. And third, find total surface area of the complex solid, which is the sum of the curved surface areas of each of the individual basic parts. You can observe and see many examples around you. Even in a pencil, you can see a combination of basic solid. If we closely observe, we can understand pencil is a combination of a cone, a cylinder and a hemisphere. So, the total surface area of the pencil is equal to curved surface area of the cone plus curved surface area of the cylinder plus curved surface area of the hemisphere. Let's see another example in the form of a problem for better understanding. Problem. A toy is in the form of a cone of radius 3.5 cm mounted on a hemisphere of same radius. The total height of the toy is 15.5 cm. Find the total surface area of the toy. Let's see the solution. Total surface area of the toy is equal to curved surface area of the hemisphere plus curved surface area of the cone. First find the curved surface area of the hemisphere. We know the radius of the hemisphere is equal to radius of the cone, which is equal to 3.5 cm. Now curved surface area of hemisphere, the equation is 2 pi r square. Substitute the value of pi and r. We get 2 into 22 by 7 into 3.5 square, which is equal to 2 into 22 by 7 into 3.5 into 3.5. Again simplifying 2 into 22 into 0.5 into 3.5, and on solving we get 77 cm square. Next, find curved surface area of cone. We know curved surface area of cone is given by the equation pi r l. Radius of the cone is equal to 3.5 cm. Now what is the height of the cone? Height of the cone is equal to total height of the toy minus radius of the sphere, which is 15.5 minus 3.5, and we get it as 12 cm. Now we need to find slant height, that is L. We know that L square is equal to h square plus r square, which is equal to 12 square plus 3.5 square, and you get 144 plus 7 by 2 square, which is equal to 144 plus 49 by 4. Simplify 144 into 4 plus 49 by 4, and we get on solving 625 by 4, or L is equal to square root of 625 by 4, that is 25 by 2, or is equal to 12.5 cm. Therefore, curved surface area of the cone is equal to pi into r into L. Substitute the values. We get 22 by 7 into 3.5 into 12.5, and it comes out 22 into 0.5 into 12.5, and we get the answer as 137.5 cm square. So now we are able to find the total surface area of the toy, which is equal to curved surface area of the hemisphere plus curved surface area of the cone. Substituting the value 77 plus 137.5, which is 214.5 cm square. Hence, the total surface area of the toy we have calculated, and we got it as 214.5 cm square. Let's see the next problem. A cubical block of side 7 cm is surmounted by a hemisphere. What is the greatest diameter the hemisphere can have? Find the surface area of the solid. Let's see the solution. The hemisphere can occupy the whole of the side of the cube. Hence, greatest diameter of the hemisphere is equal to side of the cube, which is equal to 7 cm. Now, the surface area of the solid is given by surface area of the cube plus curved surface area of the hemisphere minus base area of the hemisphere. Here, the base of the hemisphere falls on the cube, so that the area should not form that part of the solid. Therefore, we subtracted the base area of the hemisphere. Now, first find the surface area of the cube. Here, A equal to side is equal to 7 cm. Now, what is the area of the cube? Area of the cube is equal to 6a square. Substituting the value, we get 6 into 7 square, that is equal to 6 into 49, and we get it as 294 cm square. Now, find the curved surface area of the hemisphere. Diameter of the hemisphere is equal to 7 cm. So, we can find the radius. Radius equal to diameter by 2, which is equal to 7 by 2 cm. Now curved surface area of the hemisphere, which is equal to 2 into pi into r square. Substituting the value, we get 2 into 22 by 7 into 7 by 2 into 7 by 2. And on solving, we get 11 into 7, which is equal to 77 centimeter square. Now we need to find the base area of the hemisphere. Base of the hemisphere is a circle with radius equal to radius of the hemisphere, that is equal to 7 by 2 centimeter. Now base area of the hemisphere is equal to pi r square. Substituting the value, 22 by 7 into 7 by 2 into 7 by 2, which is equal to 77 by 2 centimeter square. Now we find the surface area of solid, which is equal to the surface area of the cube plus curved surface area of the hemisphere minus base area of the hemisphere, which is equal to 294 plus 77 minus 77 by 2, which is equal to 294 plus 77 minus 38.5, and we get 371 minus 38.5, and on solving we get 332.5 centimeter square. Hence the surface area of the solid is calculated and we got the answer is 332.5 centimeter square. It may be noted that in calculating the surface area, we have not added the surface areas of the two constituents because some part of the surface area disappeared in the process of joining them. So let's have a recap of what we have covered in this section. We have seen various combinations of solids and we were specifically discussing their strategy used to find surface areas of combinations of solid while solving such problems. When you get a question to find the surface areas of combination of solid, the very first step is to identify which basic solids like cone, hemisphere, cylinder, cube, etc. make the given complex solid. Next, we have to find the curved surface area of each of the individual basic parts. And the final step, we need to find the total surface area of the complex solid, which is the sum of the curved surface areas of each of the individual basic parts. Also, we have gone through a few problems for the better understanding.